Okay, so this is tangent lines and rates of change, which without a doubt is not an exciting topic for me, not at all, but I must press through. Okay, so tangent lines. Of change. And here we go. For the function f of x equals 3 times the square of x at 2, and the point P given by x equals -3, answer each of the following questions. For the points Q given by the following values of x, compute, accurate to at least 8 decimal places, the slope MPQ of the secant line through points P and Q. Okay, so here's how I'm going to do that. I'm not going to use a hand calculator, and I'm not going to type it out because that would take way too long, and I learn absolutely nothing from doing that. Instead, I'm going to use spreadsheet software. And yes, I could use an LLM and just do it all instantaneously. But you have to think about what's actually going to benefit. Your mind. So, this will be, I will head the title that Q. And I will call that M of PQ. And then here I will insert my formula. So let's see. Right, so I want the, let's think. So what is it that we want to work out? So these are the values of x. All right. Let's think it through. For example, So I don't ultimately want to end up looking like that. Right, now I know I could just instantly get all this, but I want it to be sort of laid out in a way that really demonstrates that I understand what's happening. All right, so okay, so I'll do that. And okay, so fine, so it doesn't do that. Right, how am I going to do this? Yes, I'll lay it out like this. And then something like this, just to make it real clear that I understand this. Three times A4 plus 2 squared, of course. Yes, of course. Now 3 times B4 plus 2 all squared. What's the error? Okay. And now the slope of the secant line that passes through points P and Q will be the change in the y values, so d4 over d over c4. And there you go. All right. It's not terribly appealing how that looks. Okay. I should have a border around it as well in the future. Anyway, so use the information from part A to estimate the slope of the tangent line to f of x at x equals -3 and write down the equation of the tangent line. So the estimated slope is 1. Now, as p is -3, comma, 3, we use y minus y1 equals m x minus x1. So that's 3, and then we have to add 3 to both sides, so y equals x, that's 6. So that's my answer to question 1. That's my answer to question 1. Let's see if I actually got it right. Okay, good. So their table looks a little bit similar to mine, but hold on just a minute now. Why is this not in an agreement? Right, okay, so this is completely wrong. Right, fine. Fine. It's minus 3. It's plus. Plus. Of course it's plus. Well done. Come on. That sets up my vertical part of the triangle. What sets up my horizontal part? Nothing. So this is wrong. And that needs to be over there. Oh, cool. Okay. How does one phrase this? We're just going to say Q take P. There. Now, this should be D4 take C4. That's a change in the Y value. There, that's better. All right. Ridiculous. There we go. Now, the estimated slope is 6. So I'll change that to 6 and rework it. So it appears to be 6x plus 21, but I know this is wrong. Yeah, I know. So how do we continuously get it wrong? What is it that needs to be fixed? Oh, first of all, just ignoring the minus sign. Oh, gosh. Right, so minus 6x minus 15. Okay, it is fixed. That's good. All right, problem 2. Here's the function g of x, which is the square root of 4x at 8, and the point P is equal to 2. So we build on our previous work. This time, the p-value is given as 2. So that's what my value will be there. And this time, here are my q values. And we now work out what f of p is, which will be the same in every single case. So it's going to be 4 times, let's just say a4 plus 8 all to the 0.5. And that takes up the whole column. And here, four times, which value? The q value, so b4 instead, but plus 8, and raise it to the 0.5, and there we go. And q minus p is just fine, and there, that's just fine. Now, we don't actually need this column here. What we really need is to recognize that we want a difference on top of another difference. This is b4 take a4, so that, take that. So this should really be b4. Just like that. Then extend that down, there should be no change. And so we actually don't need that column. In fact, it kind of gets in the way. And this really captures the essence of it. Here, this is just fine. And here we go. Use the information from A to estimate the slope of the tangent line to g of x at x equals 2 and write down the equation of the tangent line. So there's A. And here's part B. We recognize that it's homing in on 0.5. So we use M 0.5, and that indicates that it's an estimate. The point in question, P, which we know to lie on the secant line and does not change. P is 2, 4. And so we use y minus y1 equals mx minus m times x minus x1. Minus 1, and then add 4, so plus 3. So something like that, and there's the notation that I've made myself. Good. Problem 3. Here's my function w of x. Notice here that I didn't change. Not good. I want to get into the habit of thoroughness. The habit of thoroughness. These actions here are pointless and fussy, but they build up to a habit, to a reflex of attention to detail, which I need in this domain. Fine, ln. Okay, it's as I thought. Oh, right, of course, because I'm not in formula mode, so it's not going to bring up suggestions, is it? Okay. This time, the p-value is given by 1. And that's throughout. This time, the q value, the qx coordinate value is 1.5, 1.1, 1.01, 1.001, 1.0001, and 0.5, 0.9, 0.99, 0.999, and 0.9999. Notice that we're homing in on the value that we actually care about. Now we have to feed a4 into that function. So ln 1 plus a4 to the 4, close brackets, and extend. Then we must feed b4 into the function. First feed the p-value in, then feed the q-value in. Ln 1 plus b4 to the 4 and extend it. Proof of work. M is estimated to be 2, and the p coordinates 1, comma, ln 2. No. Let me just say what it actually is that I'm making. The estimate of the tangent of P is that, and then that, and then minus 2 plus ln 2, which you may guess. Got it. Moving on. We should title this VT, V of t. Volume of air in a balloon is given by V of t. So does this function actually make any sense? As time progresses, somehow it's what? We actually don't even know what t actually is, but okay, as time progresses, yes, it would be 6. Well, it would be, well, it would work like that, I think. Now notice that the independent variable thus far has been x, and now it's changed to t. And if you didn't notice that, then you'd be speaking nonsense. So these have to actually change to t. These are wrong as well. All right, so we're improving in accuracy. Of the volume of air in the balloon between t equals 0.25 and the following. So I recognize that that is Q. That is playing the role of Q. Rather, it's playing the role of the t value of P. So here, 1 followed by 0.5 followed by 0.251 followed by 0.2501 followed by 0.25001 and 0 followed by 0.1 followed by 0.249 0.2499 0.24999. Then we must compute the, so it will be 6/4 times A4 plus 1 throughout 6/4 times and that. And then here, there appears to be a little bit of a problem here. Right, okay. First of all, I don't think that has any effect on things, or does it? I'm just being silly. No, it doesn't. It doesn't have any effect. Okay. No, it should be fine. What is going on here? Oh, I see. Oh, it's inaccuracy now. Better. Okay. So we estimate m to be 6. No, negative 6. It's not actually. Right. Use the information from A to estimate the instantaneous rate of change of the volume of air in the balloon at T equals 0.25. So, instantaneous. No units were given, so I'm just. Okay. Now to check. Okay, so that was correct. The population in hundreds of fish in a pond is given by this function here. Answer each of the following questions. Compute accurate to at least 8 decimal places the average rate of change of the population of fish between t equals 5 and the following values of t. Make sure your calculator is set to radians for computations. All right. P of t equals 2t plus sine 2t, take 10. And do not confuse and so here the default value is 5 that we are pinpointing our focus on. And then now you know what? We're going to call it pop. Because I think it's a fundamental error to do that. Two times a4, take 10. Close enough. Right, that all makes sense. The estimated instantaneous rate of change, t equals 5. See if that's true. Okay, you got me. Sixth one. The position of an object is given by that. Answer each of the following questions. So here is the function. Now what we're going to do is we're going to write cosine of 3t just like that. And the default population number that we're homing in on is that. No, the default time that we're homing in on is 2. 2 what? We don't know. 2 seconds, 2 hours, we don't know. But it's 2. The time value is 2 that we're homing in on. And Q is the other point. And 2.5, 2.1, 2.01, 2. Those are from above. These are from below. And now the actual function in question is there. And there it's been renamed appropriately. And now comes the part where we enter it right. A4 take 6. But hold on now. We've got to bracket that numerator. Divide it all by the denominator. And then we close off the cosine function. And then we close off that. And then we have to square it. And we see if it's capable of doing that. And it seems to be fine. Okay. Now we take the function we just created, put it here. This time we feed in not A4 but B4. And extend. And upon doing so, the instantaneous velocity of the object appears to be 0. But let's see. Use the information from A to estimate the instantaneous velocity of the object at t equals 2 and determine if the object is moving to the right or moving to the left or not moving. So it appears to not be moving. That's my conclusion. Let's see if it's right. Final one to think about here. This time, eight minus t times t plus 6, 3 over 2. A4 is the focus here. So 8 minus A4, that's the first one. The next one, A4 plus 6, and that'll be raised to 3 over 2. This time it's B4, B4, and we'll extend this. So it appears to be approaching 76. Use the information from part A to estimate the instantaneous and determine if the object is moving to the right or moving to the left or not moving at all. The object appears to be moving and we check. All right, that's all valid. And now to save this, tangent lines and rates of change. Next up, the limit. All right, so what's going on here? So we can call this calculus 1. What was that previous section called? Tangent lines and rates of change. Great. Got it. Okay, so it's real tempting to just copy and paste my previous work. But we must not do that, because that will lead to not knowing what's actually going on. There's the function. Now, we do the standard approach of having 2 points, P and Q, which serve as secants, which are homing in on the tangent value. But hold on just a minute now. Now, we can't actually put in 4 into this question, can we? No, we cannot. So this, I mean, I'm in such autopilot right now that I'm not even paying attention. So what should we call it then? Just call it A. Just call this B. 1.5. Yeah, A for above and B for below. I like that. I never noticed that before. All right, and so no, there's no need to do that. And auto, and so we say 3. It's homing in on 3. based on and we'll check and see if we're right about that. All right, that's good. Now that was f of x. So we will title this sheet accordingly. And here we have the function r of t. So we write it in to take, wait, is square root a legitimate function on here? Good. All right, so it is. So now let us define this actual function. Right, well, I just wrote it out, didn't I? Put a4 there, a4 there. Now, so we estimate that as it approaches -1, from both sides, it tends to the limit of 0.5. There. And we must check. Correct. Question 3. Here we have theta. And I'll go out of my way to use it, just because I like it. Why shouldn't I? But don't we want this? Oops. Okay. Estimate the limit to be 7. That seems sound to me. All right. Okay, that's correct. Below is x, piecewise function. For each of the given points, determine the value of f of a and the limit as x approaches a of f of x. If any of the quantities do not exist, clearly explain why. All right, I'll take on each one and then I'll check. So what can we say? How do you? What's the notation again for? If we can recall the notation. 3 to the minus. So I'll say minus 3 to the minus. That's what I believe, but we'll soon see. I haven't written f of x. All right, so here we go. Mm-hmm. Wait a second, hold on. I misread. I'm sorry, that was an absolute blunder on my part. I really did mean to write 1. I don't know why I was obviously looking at that, but anyhow. I know. The limit only depends on the values of the points around the point in question, not the point itself. Okay, yep, I understand that. And that's true. All right. Yeah. Okay. Below is a graph of f of x. For each of the given points, determine the value of f of a and the limit as x approaches a of f of x. If any of the quantities do not exist, clearly explain why. All right, for a equal to negative. So, I mean, this is more or less the same as before. So I'm just going to say the limit as x approaches negative 8 of f of x is apparent. Now, a equal to negative 2. The limit as x approaches negative 2 of f of x does not exist. As the right limit does not appear to exist, and both must. But even if it did, it would have to equal the limit as x approaches right, so for a equals 6, a equal to 6. The limit does not exist. This limit does not exist. As well, because why? Say why. The limit as we approach 6 from the left, and the limit as we approach is apparently 5. And they must equal. All right, 10. Wait, what am I saying? 10. Okay, 10. Okay, so. All right, fine. The limit as x approaches 10 of f of apparently 0. And everything must be checked. Okay, that's correct. So is that. Last one here now. Below is the graph of f of x. For each of the given points, determine the value of f of a and the limit as x approaches a of f of x. If any of the quantities do not exist, clearly explain why. Okay. It doesn't seem to exist. Does not exist. Does not appear to exist. As. What's that vertical line right there? That vertical line is x equals -2. Appears to be a vertical asymptote. And obviously f of -2, well, no, I shouldn't say that actually. I'm just going based on appearances right now. I don't actually have the data or the definition of the function. Okay, so the limit as x approaches -1 of f of x is what? 1. Appears to be 1. And I'm going to say, even though f of -1 is 3, it does not depend on what the function is actually evaluates. Okay, so next up is this. This is a discontinuity, or so it appears to be. No, it is a discontinuity. It's a hole. It's a hole in the function, right? Okay, so the limit as x approaches 1, f of x is apparently -3. And finally, this one. Right, okay, check, check, check. Does not appear to exist. Good. Correct. 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 Okay, that was a lot of work there. Who's next? Who is next? One-sided limits. All right. Below is the graph of f of x. For each of the given points, determine the value of f of a, the limit from the left, the limit from the right, and the limit, the two-sided limit. Okay. If any of the quantities do not exist, clearly explain why. Right. Let's do it. -4. From the left, it appears to be 3. And the limit as x approaches -4. From the right, appears to be -2. And the limit as x approaches -4. In general, does not exist. Same question, but for -1. So I'm just going to say this. For next, this one. Which we're approaching 2 from the left. On the left. That would be -1. As you approach it from the right, that would be +5. And therefore, the limit as you approach 2 does not exist because they have to agree. For D, is equal to 2. Same for the others. Check. Check, check, checky-roo. 3, -2 does not exist. Good. 4, 4, 4 exists. Okay, great. -1, 5 does not exist. Agreed. 2, 2. 2 one-sided limits, so we know. Okay, so that's good. Below is the graph of f of x for each of the given points to determine the value of f of a. Oh, exactly the same. Not a problem. Not a problem. Okay. What the hell is this? It's nothing. It's nothing. The limit as x approaches negative left appears to not exist. Get a microscope. You can't see it. It does not exist. I don't think so. I don't think so. Now, as you approach it from the right, we get the nice -1. So doesn't exist because I have to agree. This one as a equals 1. We're just going to say this, that as x approaches 1, its function is 3, apparently. Same for others. For 3, anyway. Whoa, wait. That, oh wow, I didn't know that did that. Okay, so I have an eraser tool now built in. So it's 1. So it's -3. And therefore, the limit as x approaches 3 f of x does not exist. D, we have this. The limit as x approaches of f of x is equal to 4. Same for others. Okay. Check. Correct. 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 Now, sketch a graph of a function that satisfies each of the following conditions. Okay. I need, so I'm going to go here, go to GeoGebra, and borrow a bit of the XY plane. Yeah. Grab this like this. Just that much will be fine. Okay. So we need a graph that as you approach 2 from the left, you get 1. Like that. as you approach 2 from the right, you get -4. And f of 2 itself is 1. F of 2 itself is 1. So I'm going to do the most boring and safe function in the entire universe. This. And then what I'm going to realize is that I have a dot there, which is not allowed. It needs to be a hollow dot. Just there like that. There. So many possibilities, but will he be as boring as me? Impossible. Nobody can beat me at being boring. So, that's fine. Sketch a graph of a function that satisfies each of the following conditions. So I will borrow the same amount, copy and paste. The limit as you should be 0. Wait. Oh, there. As you approach 3 from should be 0. You know what? I have an idea. Do a hollow dot and then just do a tiny little tail like that. Yeah? As you approach 3 from the right, it should be 4. So again, another little hollow dot and a tiny tail like that. And f of exists. Okay, that's good. Now, the limit as you approach -1. No, the limit of -1 is -3. Okay. And f of -1 itself is 2. So I should have done a hollow dot there. And like that. That would be good. Okay, and f of -1 itself is 2. There like that. Now, how to connect everything. So I'm going to connect that to that. Linear. Straight line. And then that can just go, and that can go like that. And we check. Okay. That's good. That's good. Right, save. One-sided limit. Or limits. Who's next? Limit properties. I don't have enough knowledge to do this, so I need to study. I need to study. Be well, be well.